Hey everyone, I'm here to help you solve a projectile problem, specifically the projectile problem number 1 on your problem packet for your launcher. I had a video going and I was almost to the end of it, and then I was interrupted, so I thought, well, I'll keep my work, show you what's going on there, and if you need me to go back and redo the whole thing, I will, but I'm going to walk you through the steps anyways. All right. So up here, we'll start up here with our situation. All right, we have our launcher, and the launcher is actually going to launch 0.6 meters high, or 2 feet. All right, is where the beanbag is going to be released. It's going to travel 5.2 meters horizontally, or if you got 17 feet, that's there. All right. Your board it's like 1.26 meters long, so I just called it 1.3. If you kept it 1.26, we'll get a slightly different answer, and that's okay. And then the board is 0.3 meters tall. All right, so that's kind of our situation there. Going back up here, so the launcher is going to launch the beanbag at 25 degrees. All right, and so it'll launch 25 degrees. And we need to think about the component, what's going on with the vertical component and the horizontal component. All right, so vertically, this is going to be our initial velocity in the x direction. And as you remember, once you have an initial velocity in the x direction, it's going to stay that velocity. So your final velocity in the x direction will equal your initial velocity in the x direction. All right, and then I went ahead and put in the initial velocity in the y direction, which we'll use in just a little bit. So breaking it down into components. All right, I said that it would travel in the distance in the x direction would be 5.2 meters. That's fine. Remember that in this problem that we're having to find a minimum and a maximum velocity. All right, and so that's why it's horizontal man and vertical man, and breaking those things down. So minimum, all right, so at the lowest point, it has to go 5.2 meters to be on the board. All right, so 5.2 meters is how far horizontally it has to travel. If you want to say the final position in the x direction is 5.2 meters, totally good with that. All right, you're on the right track. It's just a different way of saying the same thing. Right. We don't know how long it took to go the 5.2 meters horizontally. We'll come back and figure that out in a little bit. All right. Going back to our triangle. All right. We have the horizontal velocity, and we have the initial velocity, and we have the initial velocity in the y direction. All right. Since this is our angle, so initial velocity in the x direction becomes your adjacent. The initial velocity is actually the hypotenuse. All right, so adjacent and hypotenuse go into a trigonomic function, and so the cosine of 25 is going to equal the initial velocity in the x direction, being your adjacent line, over your hypotenuse, being the initial velocity. All right, so I just got that from right there. To calculate things, it's like, well, I need to figure out time because I don't have that. You can think, and how far is it going? So my final position, all right, or my distance, if you want to go along that track, is going to equal my initial velocity times time. All right, my initial velocity in the x direction times time. Because remember, I said that you have the final and the initial are going to be the same, so you don't have to mess with the acceleration at all. All right. And then, so once I have that, and going back to my trigonomic function, I wanted to get rid of my fraction here. And so what I did was I just said that my initial velocity in the x direction is going to equal my initial velocity times the cosine of 25. All right. All I did was just clear this fraction, multiply both sides by the initial velocity, and that's how I got there. All right. And then going back once more, I'm looking at this equation because I need to figure out how do I find time. All right, so I just plugged in my numbers. I said 5.2 for my final position in the x direction. For my velocity in the x direction, I just substituted in the initial velocity times cosine of 25 times time. All right, and that's what I set up there. And since I wanted to try and solve for my initial velocity, because that's what our end goal is, to find the minimum initial velocity in this set, all right, I went ahead and moved cosine of 25 times t over here. To do that, I divided. So my initial velocity is equal to my 5.2 meters divided by cosine of 25 times time. And I'm leaving things there for now, all right, because I'm going to have to come back to that later. Going over to my vertical components, all right, you checking things out. Because it's being launched at 0.6 meters high, the minimum is the ground level right here. This is going to be ground level, so it's going to have to fall 0.6 meters. So my distance in the y position is negative 0.6 meters. Or if you want to say that my final y position is negative 0.6 meters, that's fine too. All right. Then you have your acceleration, which is gravity, negative 9.8 meters per second squared. We still don't know the time, but we know that this time is going to be the same as that time, so that'll give us some help a little bit later. And going back to our triangle, all right, so here, remember we set up that this was our initial velocity in the y direction, which gives us that nice 90-degree angle right there, which helps once again to say that this is the hypotenuse. All right, so now we're dealing with the opposite of theta and the hypotenuse, so we can use sine. So the sine of 25 is going to equal our initial velocity in the y direction over our initial velocity. Doing the same thing once more, clearing the fraction, having the initial velocity in the y direction is equal to our initial velocity times the sine of 25. All right, same thing we did right over there. All right, now we're ready to go into a kinematic equation. All right, if you're thinking about the fourth equation, all right, I just said it's the YF instead of the XF, all right, just because that's what we're dealing with in the vertical situation, and that's what I'm working with here. All right, so it's the y final equals the initial in the y direction times time plus 1/2 at squared. All right, so my YF, I pulled from right there, all right, negative 0.6 meters. My initial velocity in the y direction, all right, I solved for the initial velocity in the y direction, and it's the initial velocity times the sine of 25. All right, so if you're checking it out, initial velocity y is going to equal my initial velocity times the sine of 25 times time, because there's my time right there. All right, so a lot of substitution here. Then I add my half of acceleration, which is gravity times time squared. All right, hopefully you followed all that. If not, let me know. If I need to start from scratch and walk you through it, that's fine. I don't mind doing that. I just was trying to cut a corner right here. All right, so going back through things. All right, so now we need to substitute once more because we still have initial velocity and we have time. All right, remember over here we solved for our initial velocity. All right, our initial velocity equals 5.2 meters over the cosine of 25 times time. All right, so now we can substitute that in, and it will look negative 0.6 meters is going to equal 5.2 meters divided by the cosine of 25 times time times your sine of 25 times time plus, just bringing this down now, negative 9.8 meters per second squared, t squared. All right, from here it's just basically solving for time now, because now t is our only variable in this. All right, this time and that time is going to cancel out. All right, so you don't really have to worry with that. You can start to throw things in your calculator now. Negative 0.6 meters is going to equal 5.7 meters times your sine of 25. And I'm just doing this step by step. If you wanted to throw it all in at one time, you're more than welcome to. Minus your 4.9, it changes the sign because you're multiplying times a negative, so 4.9 meters per second squared times your time squared. All right. So if you want to put that in parentheses, you're more than welcome to. You can do that. Continuing to go along, once you multiply 5.4 times the sine of 25, you end up with 2.4 meters. All right. So negative 0.6 meters is going to equal 2.4 meters minus 4.9 meters per second squared. Hopefully you're jumping ahead of me at this point and you're just going crazy solving right now because you see what's going on in the world. All right, moving things around a little bit. I'm going to move 4.9 on this side of the equal sign and 0.6 over here. So it's going to end up changing my sign where it's going to be 4.9 meters per second squared is going to equal 3 meters. And you're like, whoa, wait, something's missing, isn't it? Yep, forgot the time squared right there. All right, so time squared, let me just erase this, make it a little cleaner for you. So 4.9 meters per second squared times time squared, all right, is going to equal 3 meters. All right, just adding this to both sides, 0.6 plus 2.4, you get 3. All right, now I'm going to try to solve for t now, which 4.9, check it out. And remember your rules about dividing by fractions is that you're going to get the reciprocal of this. And so your time squared is actually going to equal 0.61 seconds squared. All right, getting the square root, bam, bam. Time equals 0.78 seconds. All right, so now we have our time. All right, there's our time right there. Now, since we have our time, we can go back right over here, plug time in right there. So my initial velocity, once I do initial velocity equals 5.2 meters over your cosine of 25 times your time, which is 0.78 seconds. Yes, sir. My initial velocity is 7.35 meters a second. Again, this is my minimum velocity. So my initial velocity minimum needs to be 7.35 meters per second. If you came close due to rounding or significant figures or whatnot, great. Hopefully that'll set you on track. All right, remember I said that you needed to actually find the minimum and the maximum. All right, so hopefully by me finding the minimum gave you some idea about how to solve for the max, because you go through these same exact steps. All right, the things that's going to change is that with your maximum, you're now going, instead of 5.2, you're going the full, you're going your hypotenuse right here, all right, which your hypotenuse I think was 1.22 meters, I think is what your hypotenuse was, is what's going on there. So you can have that. So it's 1.2 meters further, this, or 1.3 rather, is you're going to go 1.3 meters further. So your distance in the x position is going to be 6.5, and your distance in the y position, instead of falling 0.6, it's actually just going to fall 0.3 because we're going to hit the top of here. All right. So again, your horizontal final is going to be 6.5. Your vertical final is going to be negative 0.3. All right. If you need help, if you need me to finish solving this out, I will. Great. If not, I hope this helps you out. Oh, give me a thumbs up if you like it.